Dear learners, in the course of Artificial Intelligence, today we are going to see a simple project using machine learning. So here the data set what I am going to consider is it's a diabetic database. It's in the form of CSV. See that this set of codes will import my packages and this line will read my data from the CSV file. So where is that CSV file? As usual, you have to upload it in the collab. See here, I have uploaded here diabetes.csv. After uploading this file only, you need to run this. So no need to install any packages. Most of the packages are built in collab itself. So no need to use pip command here. So I am going to print what are all the columns available in the CSV file, right? So they have printed the columns here. You could be able to observe. These are all the column names: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, outcome. This outcome is the class variable which could be able to differentiate based upon these 8 parameters whether the patient is having diabetes or not, or threat or not. So it could be classified as 1 and 0, right? So that's the last column will decide about that. I'll show you that. So next segment, diabetes.head. It is a command in Python that could able to fetch the first 5 records in the table. You could able to see these records, right? It is retrieved from that. All that 8 fields. See that 9th field you need to understand here. See that. See this field. Could able to observe this. So here you could able to find out 1, 1 and 1. It represents that patients are having threat of diabetic. So the terminology, the class variable 0 represents that they don't have that threat or they don't have that disease. So likewise the data is available in this. So 8 parameters will conclude this outcome. How they are doing this? That's what we are going to see. What is the dimension of this database? Nothing but what is the how many number of columns and how many number of rows are there. So totally we are having here 768 records are available. So already we have seen what are all those 9 fields. Okay, see that it's an important method in the same method that we have studied in Oracle and SQL also, group by. So based upon the column group by, we have consolidated. Already we have seen 768 records are available. So among that 768, 500 patients are not having the threat of diabetic, but 268 patients are suffering from or having the threat of diabetic. So that's what this command is ready to retrieve, right? Next, the same thing that I have displayed using a graph, right? Even this package also available in the collab itself. The same thing, outcome. So don't have the threat 500, having the threat that we have seen 268 has been plotted in the graph. Okay, again .info command will retrieve me the along with their field entries, right? Consider this is the first field, pregnancies. So there they have restricted how many number of entries are available, right? Non-null, that represents that there are no null entries. Data type of the respective column is integer, right? So this is what they have represented very clearly. So this especially this non-null will represent that we have processed data, right? We no need to clean the data, it is already processed. Next, so now we are very clean about our data. What is the next section? We need to use a algorithm to check and to train and to test our data set. So for that, sklearn is a famous package available in the Python derivatives. So using that, I am going to create a model out of the algorithm KNN. So how I am going to split the data. So for training accuracy and for testing accuracy, I need to split. So which column that I need to omit, that has been mentioned here, because that is the column that we are going to check across with. That is what, this is the column that I need to omit, that has been mentioned here very clearly. And next, so using that algorithm, I am going to work with, so how many neighbors that we could able to check, that means how many clusters that we could able to frame with. So here they have been mentioned as from range 1 to 11, these many number of neighbors that you could able to create, that is the range. By varying that range, you could able to come to a conclusion that where testing and training could able to meet. So I am building the model. See that this is the built-in method for KNN algorithm. Here I have mentioned the neighbors. Already neighbors are going to be checked for 1 neighbor, 2 neighbor, 3 neighbor, 4 neighbor. Likewise, up to 11 neighbors will be checked. Every neighbor's content is going to be plotted here. Every iteration, when I am going to n equal to 1, what is my training accuracy and what is my testing accuracy. Likewise, it is going to generate me a value that is going to be dropped in the graph, right? So for n equal to 1, how this will generate. For n equal to 2, how this will generate. For n equal to 3, how this will generate. So likewise, you are going to see up to 11. Right, so those things are being generated. These are purely used for plotting the graph. Right, this command is used to generate and save the graph. Save the graph in my local collab itself. You could able to see this here. See that knn-compare-model.png. So in the name of png, in the extension of png, it is going to save. Right, see that output of the graph. So it is going to, this is my training accuracy. See that they are ready to come down. It's in highest value of 1, and it is going to converge and ready to meet here at a 10. Not to meet, going to intersect. As well as testing accuracy, see here how it is going to travel. So here the primary point is the best place or the best n value, how to identify. So that can be identified between these I think close to 2. So this is the place, right? It may overfit. So this is the place that we could able to identify. So how to find out that? So here the neighbors values are between 8 and 10. So why don't we give the values between them? That will serve us something a meaningful one. So that's the reason why that n value is going to be changed as a 9 here. So here you might have seen this. These values are being separated from this for loop, from this range. From 1 to 11 they have checked, but between 1 to 11 somewhere else only we are getting the very good accuracy on training and testing. So how to find out that? By giving that value n equal to 9, again you fit that model. X values and y values are get to fit, and I am ready to generate the score. So the score value is 0.79 during its training set, 0.78 during its testing set, right? So this could be the best n value that it is ready to classify. What does this mean, this 80% here ultimately? So round it to be 80%. We are having 768 data, right? Among that 768 data, 80% of data are being correctly classified. Rest of the 20% of data, they are ready to move here and there. Tolerance will be there always, right? So 80% of the data they are ready to classify using this model. So remaining 20% of the data are negligible here. That means they could not be able to classify. That is the idea here. So classification, what are all the algorithms are available? So learners can try with the other algorithms. Even in the forthcoming videos we will ready to discuss. So here we have used KNN algorithm, K nearest neighborhood algorithm. So you can check with other algorithms too. So something interesting to work with here. So how to improve that? Now here we are having only lesser number of data. So training a model with lesser number of data will not be fruitful. So this is for our case study only. So you could be able to increase the size of the data, you could be able to increase the size of the records, so that will fetch us the best model, because the number of times that we are going to improve that learning, ultimately number of times that we are going to give a huge number of data to be practiced, that much number of effective model will be there, as well as updated data will help us in a better way, right? So that's the idea behind this case study that we have discussed about a simple project that could talk about that diabetics threat, right? So here we have trained the model completely. Now it is ready to predict. So I left you how to do prediction. So you please check over on the materials and try to continue this work by giving a new value, right? How to check with that? So here the algorithm is trained here. So you have to supply these 8 values: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age. By giving these 8 values, you need to find out the outcome. That means that model need to find out the outcome that it is 1 or 0. That is what the prediction phase applicable for your algorithm. So the rest of the part is left over to you. You try to complete and submit the same through our e-learning portal. So thank you and happy learning.